Recall the sum from n equals 1 to infinity of a sub n, x minus c to the n, equals a sub 0 plus a sub 1 x minus c, and then a sub 2 x minus c squared, and then a sub 1 x minus c to the n is a power series centered at c, where c is a constant. For a power series centered at c, precisely one of the following is true. 1. The series converges only at c. 2. The series converges for all c. 3. There exists an r greater than 0 such that the series converges, for the absolute value of x minus c is less than r, and diverges for the absolute value of x minus c is greater than r. R is called the radius of convergence of the power series. In part 1, the radius is 0. In part 2, it is infinity. The corresponding domain is called the interval of convergence. Let's look at letter A. We have the sum from n equals 1 to infinity of all this stuff here. We're going to use the ratio test to decide what x has to be for this to converge. So we have the limit as n approaches infinity of the absolute value of x minus 5 to the n plus 1 over n plus 1 and then times 2 to the n plus 1 times n times 2 to the n over x minus 5 to the n. And we'll have the limit as n approaches infinity. We have one extra x minus 5, so that's going to leave an x minus 5 on top. We have x minus 5. We have an extra 2 in the denominator, so over 2 to the n, and then times n over n plus 1. And as n approaches infinity, this rational function will approach 1. So we end up with x minus 5 over an extra 2. And that shouldn't be to the n. That's just one extra 2 right there. Now this is going to converge as long as x minus 5 over 2, or the absolute value of that, is less than 1. So negative 1 is less than x minus 5 over 2 is less than 1. Let's multiply by 2. Negative 2 is less than x minus 5 is less than 1. And then when we add 5, we have 3 is less than x is less than 6. The interval of convergence is 3 to 6. And then if we put this on a number line, we have 3, 4, 5, 6, and we have 3 to 6. And the radius of convergence is 1.5. So radius of convergence is 1.5, or we could say 3/2. Let's look at letter B. We have the limit as n approaches infinity of the absolute value of x to the n over, actually x to the n plus 1 over to 3 to the n plus 1, and then times, let's multiply by the reciprocal, 3 to the n over x to the n. And we have the limit as n approaches infinity of the absolute value of, we have one extra extra x on top, and we have one extra 3 in the denominator. So the absolute value of x over 3 has to be less than 1. Negative 1 is less than x. Over 3 is less than 1. And we have negative 3 is less than x is less than 3. So now the interval of convergence is negative 3 to 3. And the radius of convergence is equal to 3. Let's look at letter C. Letter C has quite a bit more going on here. We have the limit as n approaches infinity of the absolute value of, we have, well, what happens when we plug in n plus 1 in here? We have 2 times n plus 1 and then plus 1. That's 2n plus 2 plus 1. So that becomes 2n plus 3. We have x to the 2n plus 3. That's going to be over 2n plus 3 factorial because we have the exact same situation. And then multiply that times 2n plus 1 factorial over x to the 2n plus 1. We have the limit as n approaches infinity of, we're going to have 2 extra x's. We have on top, we have 2 n's, but then this is plus 3, that's plus 1. On top, we're going to have x squared. Let's look at the factorials. This can be written as 2n plus 1 factorial times 2n plus 2 times 2n plus 3. So the 2n plus 1 factorials will cancel out, and we're going to be left with 2n plus 2, 2n plus 3 in the denominator. So 2n plus 2, 2n plus 3. I think that takes care of pretty much everything. When we do the limit now, when we put infinity in the denominator, that's going to be 0. So we have 0 times x squared, and we want to know when that is less than 1. Well, that's always less than 1. So the interval of convergence is from negative infinity to infinity, and the radius of convergence is equal to infinity. Let's look at letter D. We have the limit as n approaches infinity of the absolute value of n plus 1 factorial times x minus 3 to the n plus 1, and then we can divide this by n factorial times x minus 3 to the n. This n plus 1 factorial can be written as n factorial times n plus 1. So the n factorials will cancel, and we're left with n plus 1 in the numerator. We have the limit as n approaches infinity of, we have n plus 1, and then there's going to be one extra x minus 3 in the top. So this is times x minus 3. This is equal to, if we plug infinity into n, we get infinity and then times x minus 3. And the only time this is going to be less than 1 is when x minus 3 is equal to 0. So x has to be equal to 3. The radius of convergence is 0, and the interval of convergence is 3.